Climate change is accelerating, bring the world dangerously close to irreversible change. More devastating fires in California and now Maui. Persistent drought in the southwest. Record flooding in Europe and Africa. A heat wave, of all things, in Greenland. Climate change and its effects are accelerating, with climate-related disasters piling up, season after season. Things are getting worse, said Petteri Talas, Secretary-General of the World Meteorological Organization, which on Tuesday issued its annual State of the Global Climate Report, concluding a decade of what it called exceptional global heat. It's more urgent than ever to proceed with mitigation. But reducing greenhouse gas emissions to fight climate change will require drastic measures, Dr. Talas said. The only solution is to get rid of fossil fuels in power production, industry and transportation, he said. Seas are warming and rising faster, putting more cities at risk of tidal flooding or worse. Glaciers are melting at a pace many researchers did not expect for decades. The amount of Arctic sea ice has declined so rapidly that the region may see ice-free summers by the 2030s. Even the ground itself is warming faster. Permanently frozen ground, or permafrost, is thawing more rapidly, threatening the release of large amounts of long-stored carbon that could in turn make warming even worse, in what scientists call a climate feedback loop. In a recent commentary in the journal Nature, scientists from the Potsdam Institute for Climate Impact Research in Germany and other institutions warned that the acceleration of ice loss and other effects of climate change have brought the world dangerously close to abrupt and irreversible changes, or tipping points. Among these, the researchers said, were the collapse of at least part of the West Antarctic ice sheet, which itself could eventually raise sea levels by 4 feet or more, or the loss of the Amazon rainforest. In our view, the consideration of tipping points helps to define that we are in a climate emergency, they wrote. The societal toll is accelerating, too, United Nations Secretary-General Antonio Guterres said in Madrid before the opening this week of the UN's annual climate conference. Climate-related natural disasters are becoming more frequent, more deadly, more destructive, with growing human and financial costs, he said. For individual extreme weather events or other disasters, it can be difficult to fully separate the effects of global warming from those of natural climate variability and other factors. Warming can make wildfires worse, for example, it makes vegetation drier and more combustible, but forest management practices, as well as decisions about where to build, also affect the degree of devastation. Yet a growing number of studies have shown the influence of global warming in many disasters. Heat waves in Europe in June and July, extreme rainfall in Texas during Tropical Storm Imelda in September, the drought that precipitated the Day Zero water crisis in Cape Town in 2018 are among many events shown to have been made more likely, more intense, or both, by climate change. Latest news on climate change and the environment. Protecting the Amazon. The leaders of 8 countries that are home to the Amazon River Basin have agreed to work together to conserve the world's largest rainforest at a groundbreaking meeting in Brazil. The agreement provides a roadmap to stave off the rampant deforestation that has severely damaged the Amazon and has major implications for Earth's climate. Sea pollution. A new study found that there's less plastic pollution flowing into the ocean from land than scientists previously thought. The full picture, however, is complicated. The amount of plastic in the ocean is still increasing by about 4% every year, and the amount of plastic on the sea surface could double within 20 years, according to the researchers. Ocean heat. The planet's average sea surface temperature spiked to a record high in April and the ocean has remained exceptionally warm ever since. In July, widespread marine heat waves drove temperatures back up to near record highs, with some hot spots nearing 100 degrees Fahrenheit, or nearly 38 Celsius. Antarctic sea ice. It's winter in the southern hemisphere, when ice typically forms around Antarctica. But this year, that growth has been stunted, hitting a record low by a wide margin. The sharp drop is alarming scientists and raising concerns about the ice's vital role in regulating ocean and air temperatures, circulating ocean water and maintaining an important ecosystem. A ban on incandescent light bulbs. Under new energy efficiency rules that took effect on August 1, shoppers in the United States are no longer able to purchase most incandescent bulbs. Taking their place are LED lights, which have driven down electricity demand in American homes and helped lower the nation's emissions of greenhouse gases. Effects like loss of sea ice, more severe heat waves and changes in rainfall patterns were long predicted by scientists and described in reports like those of the Intergovernmental Panel on Climate Change and, in the United States, the National Climate Assessments produced by federal researchers. So much of what we're seeing is exactly consistent with what's expected from climate change, said Philip B. Duffy, a physicist and president of the Woods Hole Research Center, which studies the environment. At the root of the changes is the basic process of global warming. As carbon dioxide and other greenhouse gases build up in the atmosphere, they trap more of the heat that radiates from Earth's surface as it absorbs sunlight. The WMO's State of the Global Climate Report, released at the Madrid talks, said that this decade will almost certainly be the warmest decade on record. And the second half of the decade was much warmer than the first, with global temperatures averaged over the second half about 0.2 degrees Celsius, about 0.4 degrees Fahrenheit, higher. All the time we're breaking records in temperatures, Dr. Talas said. The records extend to the oceans as well, which absorb about 90% of the excess heat retained by Earth as a result of increased greenhouse gases. Average ocean temperatures so far this year exceed those of 2018, which were records, the report said. Since the rise of industry in the second half of the 19th century, when widespread emissions of greenhouse gases began, the world has warmed by about 1.1 degrees Celsius. But how fast temperatures will continue to increase, and how much worse things may get, depends in large part on whether the world reins in greenhouse gas emissions, and by how much. After flattening between 2014 and 2016, annual emissions from burning fossil fuels for energy have risen again. The 2015 Paris Agreement called for countries to pursue efforts to limit warming this century to 2 degrees Celsius, 3.6 degrees Fahrenheit, above pre-industrial levels, with an even stricter target of 1.5 degrees Celsius. But the United States under President Trump is leaving the agreement, and a United Nations report last month suggested that even if countries meet their pledges to cut emissions, and many are far off track, warming would be more than twice the 1.5 degree target. Acceleration of some elements of climate change has been expected and has now been detected thanks to improvements in measurements. Sea level readings, for example, are now far more extensive, frequent and precise thanks to satellite sensors in use for the last quarter century. In the past, scientists had to rely on tide gauges. Using satellite data, a 2018 study found that global sea level rise is now about 4.5 millimeters a year, or a little less than 1/5 of an inch. The rate is increasing by about 1/10 of a millimeter a year. We knew the rate of sea level rise was increasing, but we had difficulty detecting that, said Stephen Narum, a University of Colorado researcher and lead author of the study. The study estimated that the acceleration would result in sea level rise by the end of this century of 65 centimeters, or about 25 inches, which is more than double the rise if the rate had remained constant. Sea level rise results from a combination of melting glaciers and ice sheets, and the thermal expansion of seawater as ocean temperatures rise. As with most of the projected effects of climate change, there is a high level of uncertainty about future sea levels. No one is terribly sure about what will happen by 2100, Dr. Narum said. If the ice sheets really start to go, things could change dramatically. Greenland and Antarctica hold enough ice to raise seas by about 220 feet if it all melted. Complete melting would take many centuries, but melting is speeding up on the Greenland sheet, which currently contributes about 2/3 of a millimeter to sea level rise annually, and on much of the West Antarctic sheet. This is a consequence of the warming temperatures of climate change, said Marco Tedesco, a climate scientist at the Lamont Doherty Earth Observatory at Columbia University. Overall, we do not expect Greenland to slow down, he said. And we definitely expect an acceleration in mass loss of the West Antarctic ice sheet. While the West Antarctic sheet currently contributes a small amount to sea level rise, eventually it could contribute as much as Greenland, he said. Amid the long-term increase in ice sheet melting, there have been some exceptional periods, including this summer in Greenland, when heat from Europe spread north, resulting in temperatures as much as 15 degrees Fahrenheit above normal. Overall this year, Greenland had a net ice loss of about 350 billion tons, about 20% more than the average in recent years and enough to add 1 mm to sea levels by itself. A recent analysis by Dr. Tedesco and a colleague showed that a rare combination of atmospheric conditions, related to instability of the polar jet stream that encircles Earth at high northern latitudes, led to this summer's melting. Some scientists have suggested that this jet stream instability, or wobbling, is a result of climate change, although the idea is not completely accepted. Warming in the far north affects more than ice. Louise Farquharson, a geologist and researcher at the University of Alaska Fairbanks, studies the effect of climate change on permafrost. In the Arctic, ground can be permanently frozen from near the surface to several thousand feet deep. We see warming across the board, and generally the rate of warming is increasing, Dr. Farquharson said. But the impact varies significantly. Her recent research found rapid thawing of permafrost high in the Canadian Arctic, where there is little surface vegetation to insulate the frozen ground. By 2016 the permafrost had already thawed at depths not expected until 2090 under a model of moderate global warming. While the permafrost at her study sites contains little organic matter, much of the Arctic's permafrost contains large amounts of dead vegetation built up over hundreds or thousands of years. This makes it a huge storehouse of carbon. By some estimates, Arctic permafrost contains about twice as much carbon as is currently in the atmosphere. When it thaws, the organic matter begins to decompose, and the carbon enters the atmosphere as methane or carbon dioxide, adding to warming. Bottom line, climate change is changing, accelerating, and the acceleration is even accelerating more. Want to learn more? Visit www.itsmyclimate.com. Love Shift. Working together we can make a difference.